A lot of the other Noctua videos that we've done here at Computex, this one is really not going to be about air cooling. What I wanted to start off with is Noctua has become a collaboration company, so they have such a strong brand. What they have done is they've started collaborating with other companies to bring sort of their colorways, some of the performance that they bring to the table to other brands' products. So of course we all know that there is the ROG Noctua Edition GPUs. In this case it's the RTX 5080. This thing is absolutely massive, 4.7 slots, 3 120mm fans. The idea here is to have a completely silent solution. Of course there's also been some Noctua colorways for keyboards. Finally, this is something very, very new here. This is a Pulsar Gears mouse with an integrated Noctua fan. So you get that cool palm feeling in those sweaty gaming sessions. There's also another iteration of the Seasonic Prime plus Noctua collaboration for power supplies. So what this is the PX HPD series, so a little bit less expensive than the last Noctua collaboration in lower wattages. So in this case, we have 850, 1000 watt, and 1200 watt, which does sort of overlap with the last series that Noctua and Seasonic collaborated on. In addition to that, something else that they have brought out is a collaboration with Antec. We're going to be covering that in a separate video by Dimitri in a bit.
And then we have this interesting colorway. I'm happy that Noctua is doing all these collaborations. This is a collaboration between Noctua and Pulsar. This is the Feinman F01, their flagship gaming mouse that goes all the way up to 8,000 hertz polling. It has a USB charging dock, USB-C connectivity. The mouse by itself is around 46 grams, but with the Noctua edition, they've added an internal fan that cools your palm as you game. So initially I thought, like, hold on a second, this is gonna be kind of a, you know, traditional gimmick in that space, but it actually works because, first of all, the fan is fairly lightweight. It's only 15 grams. The mouse is already very light, so you're looking at probably with the reconfiguration of the interior and a slightly beefier battery to support the additional power consumption by the fan, you're looking at about maybe 80 grams. It's not finalized, but in terms of the shape, that's identical. And it's the magnesium alloy skeleton, which looks absolutely phenomenal, even in this Noctua colorway. So that's pretty much it in terms of design. There's an on and off button at the bottom, so you can turn the fan on. We don't know about battery life capacity with the fan on, but I can feel
What you got here?
Eber, let's get cool.
That's actually really cool.
You don't feel exactly. No.
Cool me off.
Shh. Now pretend like the hair is flashing back.
I don't have enough hair, not anymore.
You will have the option to adjust the fan RPM. This thing goes up to 5,000 RPM, I think. And even though it's spinning so fast, because the blades are so small, the dB on this thing is about 19.6. So it's absolutely quiet. In this range, I cannot hear it. And so I think this is going to be, hopefully, a popular trend when done right. Really excited to check it out. Let us know what you think.
Quickly, I also wanted to touch on a new 120mm fan. We saw this last year, but it's finally going to be rolling out now in 2025. This is the Noctua A12x25 G2. So everything we all loved from the original A12, but basically taken up a notch, sort of like we saw with the 140mm fans. So it's all the same technology. You have things like a dual fan offset to make sure that if you have two of these fans that you can buy in a dual fan package, that there's not excess air noise between those two fans if they're mounted on, for example, push-pull on a radiator or on a dual tower heatsink. Also, it's going to be available almost right from the jump in both Chromax Black and your typical Noctua Beige. Like I said at the beginning of this video, it's not all about air cooling this video, it's about probably everything else. So Noctua is planning to launch in 2026 an AIO. So what we're going to have is we're going to have a 240, 360. Are we also going upsize to 140 sizes?
Probably there's going to be a 420 as well. Yes.
Okay, so I've brought Jacob here because he knows all the nuts and bolts of what this project is all about. So first of all, can you explain to us the partnership that you have here and also the focus of this engineering sample, shall we say?
Sure, with pleasure. So we've teamed up with Ace Tech for this. We've worked with them for quite a few years on this, honestly, and yeah, from our perspective, they are really the gold standard in terms of reliability, but also performance in terms of all-in-one water coolers. So it was a natural choice for a partner, and our focus has been squarely on optimizing acoustics. So we're putting on our latest A12 X25 G2 and A14 X25 G2 fans.
So what you're also doing is, just speaking of that pump as well, it is using the Asetek 8th generation V2 pump, so probably their newest pump before they go to Gen 9.
Yeah.
So other than the fans cutting down on the fan noise, the idea here is to isolate the pump noise as much as possible. So explain to me a little bit about what I'm seeing right here, because this is very unique among AIOs.
Yeah, this is a 3D printed dummy of the acoustic foam insert we have underneath the pump cover you can see here. And you can see that it's a 3-layer structure. We have these are represented in black here, 2 layers of soft, very porous acoustic foam that targets high frequency noise, and the white layer that you can see in between is a dense mass barrier that targets lower frequencies and also acts as the first mass node in the tuned mass damper I've mentioned.
So basically what we're talking about here is something very, very similar to what's inside of the top of Taipei 101 to compensate for the structure moving backwards and forwards anytime when there's an earthquake here in Taipei, which is, believe it or not, very frequent. So anyways, the other thing I wanted to talk about very, very quickly is what we're seeing here. So this is a secondary fan that is 3D printed as well. This is a prototype, guys. This might not even be the final look of everything that you find at retail. I believe it's in Q1 2026,
yeah, that's
give or take. Okay, so explain what you're hoping to achieve with this solution here, which you take off the cap, pop this on, and you've got a fan on the top.
Yeah, so that's going to be our optional auxiliary fan, VRM fan, but it's not just for VRMs because it basically will cool all your near socket components. We're utilizing a much larger fan than most typical VRM fans are, so it's our 80mm NFA 8 fan, and we've designed a custom fan frame for it that uses the Coanda effect. You can see the frame being bent out here. The Coanda effect is
there's little fins.
Fluid streams attached to surfaces, and this way we can draw out the air towards the side so that they better reach your components. And the ribs you've mentioned here, these are actually for rotational energy conversion. So the wake flow of fan has these rotational patterns, these helix kind of structures to it. And by straightening it up, we can convert the rotational energy to straight kinetic energy, just like we do with our desk fans as well.
Again, what we're seeing here is a prototype. It's not necessarily the final colors for anything that you see here. The tubes might change, a lot of things might change. What won't change though is that they are using their very good secure firm 2 mounting system with an included offset for Intel and AMD system. So what are you trying to achieve over a typical AIO in terms of, I guess, noise normalized performance, because that is very much your focus?
Yeah, so our focus, as we've discussed, has been on bringing the noise down. So we have a little performance preview here, and on average, throughout the entire RPM range of the pump, we can reduce pump noise emission by around 6 decibels. And that's compared to a pump without a cover. An interesting thing that we found in our testing is that a lot of the covers out there have those big screens on them, and some of them actually increase the noise level of the pump, basically amplify the vibration and noise coming from the pump. We've got one on display here that had a rough 3 dB increase in noise levels over the naked pump, so you will see a substantial improvement over existing solutions.
Okay. So the next thing I wanted to talk about is a little bit over here, and that is the next iteration of their research projects, shall we say, into a working thermosiphon. Can you explain to us, Jacob, very quickly where we were last year versus where we are now? What have the optimizations been?
Yes, with pleasure. So we've made good progress throughout the year. You may remember that
is so cool.
Last
you need
year,
to ship it with this. Guys, we're going to take some more shots of this, but this is freaking cool.
Probably not going to happen, but we'll see. So compared to last year, we had a non-working demo there, and now we have a functional demo here for you guys. We're running game F124 on a 9800X3D. So the purpose of the functional demo is to show we're ready to roll on current hardware. It works, but I've also have to stress that this is not a performance demo. So it's to show the progress we've made, but we're not just there yet. And the key reason for that is all on that back panel, and it has to do with the hotspots that today's CPUs have and the trouble they give us in the evaporation process.
So what are the next steps? What are the next steps of development to maybe take this to fruition, right? Maybe make this a viable product to ship to your customers?
The main focus for us right now is to really work heavily on the performance tuning of the cold plate and making sure that we get the best possible performance consistency in the evaporation process. So the trouble we're dealing with at the moment is that the hotspots of the CPUs create hotspots on the evaporator surface, and the hotter a surface gets, the more vapor you have forming at that part of the surface. And since the thermal transfer capabilities of the vapor is so much lower than of the liquid state of the fluid, this will insulate the surface towards the liquid, drop in the heat transfer curve, as you can see up there. So once you push beyond that point of critical heat flux, you will see heat transfer rates dropping significantly, and this will cause major problems for two-phase cooling solutions. So our main focus right now is working through that hurdle.
I think one of the main things that we have to remember is that a thermosiphon isn't necessarily to get insanely cool temperatures, right? This is all about simplifying the liquid cooling process, eliminating one of the main sources of noise within a typical closed loop liquid cooler, and in addition to that, eliminate one of the major fail points of that as well. So what the intent here is to get the reliability of an air cooling solution with the performance of a very, very good AIO. As of right now, there is no set date, no price, nothing along those lines. This is sort of like Half-Life 3, right? It'll be ready when it's ready.
I think you're spot on. The key benefit of working with a passive gravity-driven system like this is that we have no mechanically moving parts inside the loop. So there's zero vibration, no mechanical part like a pump that could fail, and of course no noise from a pump. On the other hand, with the system being fully passive, so no active pump pushing the fluid through the loop, and relying only on phase change and density changes to create the circulation, we have much lower circulation rates. So we have to make up for that by really optimizing the cold plate for evaporative cooling, and that's also the reason why you see so completely different structures here than you're used to with AIO water coolers.
So the last thing I wanted to wrap up with is sort of that new territory, all these things that Noctua is branching out into. We didn't talk about air coolers, and look, right now, their D15G2 is their pinnacle. It is their poster child for the entire lineup. But last year, you might remember that we did look very quickly at a dual 120mm design. And that's not here. And there's a very quick and very simple reason for that. Can you explain?
We're just not there yet. It's in the end, it's very simple. This is also the reason why we have removed it from our roadmap for now, because we're just not seeing the numbers we want to see yet. And I cannot tell if or when we're going to make it. So yeah, we don't just want to tease you guys with something where the timeline is super unclear.
So I guess that's pretty much it. Jacob, again, like every year, thank you so much. It's amazing to see where you guys are going and where you're ending up. I'm Mike with Hardware Canucks. That's Jacob with Noctua. And I'll see you in the next video, and we'll see him next year probably. Take care, guys.